Hi, here we have the two circles, each of radius 4 cm touch externally, and each of these two circles is touched externally by a third circle such that these three circles have a common tangent. Then the radius of third circle in centimeter is how much? So let's draw the figure. Let's say this is the common tangent. So one of the circles is, let's say, this, and this is the other circle. Both these circles have radius 4, okay, and they touch each other externally at this point. Now there is a third circle which is which touches both these circles externally and is also having the same common tangent. So the third circle can be drawn like this. This will be the third circle, and we have to figure out the radius of this third circle. Okay, so let's do one thing. Let's join the centers of these two circles, and the centers will pass through this point of common point between these two circles. Let's join the centers of these two circles, and this line will also pass through the points where the circles touch each other. And let's extend this line completely. So let's say this is C1, this is point P, this is center of the third circle C3. Okay. Also let's join C3 and center of second circle C2. Now if you look at this triangle C1, P, C3, this will be 90 degrees. This point will be exactly in the middle. Or how do you get 90 degrees? Basically, if you look at triangle C1, P, C3 and C2, P, C3, both these triangles will be congruent triangle, right? This side is equal to this side, same radius, and this is the common side, and this side here will be 4 plus R, and this side here will be 4, the radius of this circle, plus R, radius of this circle. So the third side is also equal in these triangles. So these two triangles are congruent, and since C1, C2 is a straight line and these two triangles are congruent, these two angles will be equal. The corresponding angle of this here will be this angle here. So since these two are corresponding angles, both these angles will be equal and they will be equal to 90 degree. Okay. So C1P C3 is a 90 degree or is a right angle triangle where this side is 4. What about PC3? Now this full side is 4, out of which this is R. This is R. So what about this part? What is the length of this part? 4 minus R. So we know PC3, the length of PC3 is 4 minus R. C1P is equal to 4, and C1C3, length of C1C3 is effectively radius of the bigger circle plus radius of smaller circle, which is 4 plus R, right? And now we know this triangle C1P C3 is a right triangle. So in right triangle we know hypotenuse square C1 C3 whole square, that is 4 plus R whole square, is equal to sum of squares of the other two sides. So we'll have 4 square plus 4 minus R whole square. Okay, so let's solve this and we'll get the value of R. So this expanded becomes 16 plus R square plus 8R, which is equal to 16 plus R square minus 8R. So 16 cancels out, R square cancels out, minus 8R goes that side, becomes 16R is equal to 16, hence R here comes out to be 1. So the radius of the smaller circle is 1. So we need to figure out the radius of the third circle, which is option B here. Thank you.